Unit 3, Part 2, Computer Programming Essentials. In this section, we're going to talk about the scope of variables and constants. And scope basically means the area in which a variable or constant is available to the program. Where can you access it? So in general, scope is from the point where you declare the variable until the end of the code block in which it is declared. So from where you declare it until you reach the first close curly brace. And scope is the same for variables or constants. It's within the block of code in which it is declared. Concatenating strings and variables and constants. So when we used a print or println statement, by the way, println, some people call that println or print line, and what that does is it will print what is in the parentheses and then return to the beginning of the next line. The print statement without the ln just prints what's in parentheses and then stays right there. Does not go to the beginning of the next line. So it's useful if you want to print more than one thing on the same line. When you concatenate a string, concatenation is a $5 word that basically means putting two things together. So you're putting two strings together, concatenation. And the way we concatenate two strings is with the plus sign. It might look like an addition operator to you, but when used with strings, it is the concatenation operator. So this is an example of what's known as polymorphism, when you have one symbol or one thing that's behaving differently given the circumstances. So the addition operator will be the concatenation operator when used with strings, or it will be the addition operator when used with integers. The entire expression, the two strings added together, become one string. They are treated as one string. And the println method can accept any number or string. We can also provide any number or string to the show message dialog method. We used it in the last chapter to display an output message, and although it says it does not accept a single numeric variable, we can concatenate a single numeric variable with the empty string. The empty string is indicated as two quotes right next to each other with no space in between them, and that empty string will cause the numeric variable to be converted to a string, which is pretty handy. Here's an example. So we import javax.swing.jobChampaign. That we need to include the definition of the jobChampaign class. Public class numbers dialog, so the name of this class is numbers dialog, followed by an open brace. And then we've got our main method, public static void main string args. That's our main method, the single entry point into every Java application. Int credit days equals 30. We've declared an integer variable, called it credit days, and stored the initial value 30 inside credit days. Then we have jobChampaign.showMessageDialog, null comma. Remember, when we're using show message dialog, null comma is always the very first thing we have to encounter inside those parentheses. And then we are concatenating together the empty string with the variable credit days. So it takes the 30 that's stored in credit days, concatenates it together with the empty string. Now the whole thing is a string, and it will be displayed in the show message dialog. The second show message dialog says every bill is due in, and concatenates that string constant or string literal with the value that's in credit days, along with the string constant or literal space days. I encourage you to hit the pause button here and go ahead and try to type up this program and see if you can get it to run. If you make a typo, if you've got some red squigglies, that's a good thing, because you'll learn something from debugging it, from finding out what's wrong. Double check your spelling, make sure that you've used the same upper and lower case as I have, and let me know if you run into any trouble. Welcome back. So the integer data type, the int data type, stores a whole number, an integer, and its value can range from about negative 2.1 billion to about positive 2.1 billion. You are encouraged to choose the appropriate type for what data you're storing. If you wanted to store the population of the world, you can't have half a person, so the population of the world would be a whole number, but would you be able to use an int? If you said no, you said the right thing, because the population of the world is just over 7 billion, and an int can only store just over 2.1 billion. So it's not big enough to accommodate the population of the world. You'd have to use a different data type. The Boolean data type only has two possible values. It's either true or it's false. It can be one or the other, but not both. So here's an example down here where it says Boolean is it payday equals false. The variable is called is it payday and the initial value is false, so it is not payday. The relational operator is also called the comparison operator, and it can be used to compare two values, and it results in a Boolean answer. The comparison operator, the relational operator, will yield either a true or a false result. Here's a nice table that illustrates that. There are 6 relational or comparison operators in Java: less than, greater than, equal to, which is 2 equal signs right next to each other with no space between them, less than or equal to, greater than or equal to, and not equal to. When you see the exclamation mark, you pronounce that not equal to. And then an example of when that results in a true expression and when it results in a false. So look at the less than row. 3 less than 8. That's true. 3 is less than 8. 8 less than 3. Oh, that's false because 8 is not less than 3. So you can see it's giving you an example of when that operator yields a true and when that operator yields a false. And you can examine that for the rest of these operators. Note for the bottom 4 operators, equal to, less than or equal to, greater than or equal to, and not equal to, there is no space between the 2 operators. It may appear that there is a space here on this slide, but that's only to improve readability. Do not hit the space bar between the 2 operators when you're typing. Another thing to point out, I've had a number of students who've gotten their less than and their greater than mixed up. So if that is a problem for you, I encourage you to make flashcards so that you can memorize which one's less than, which one's greater than. Another thing people frequently got wrong, notice the less than or equal to. It's the less than sign followed by the equal to sign. Sometimes students would put the equal sign first, and it's not equal to or less than. It's less than or equal to, and it does make a difference to Java. The next data type we need to learn about is the double data type. Double will accommodate a floating point number. That's a number that contains or has the potential to contain a decimal portion or a fraction. So 3.14159 is an example of a double, a floating point number. 5.0 is an example of a floating point number. A double allows for accommodating many more significant, well, any significant digits, whereas an int can't. An int does not have the ability to store part of a number. It's only whole numbers. So double gives you the possibility of having many significant digits. And significant digits refers to mathematical accuracy.